Let's go to page 719, and this is lesson 15-3. The objective of this lesson is to recognize and analyze normal distribution. So you have these different data, like this is the rainfall in inches, and this is the weight in grams, and light time in hours of the light bulbs. And so this is a histogram. When it plotted, it can kind of looks like a bell shape. Okay, so whenever the data can kind of approximate by the bell shape, then you can call it. You can kind of approximate by the normal distribution. So normal distribution is when the data kind of resembles some kind of bell shape. Okay, and so here, if you read this deviation over here, it's a certain distribution represented by bell-shaped curve. So like when it looks like this, it's known as the normal distribution. Okay, and a normal distribution means that with means the middle, what happened? They normalize it with a mean equal to 0, and standard deviation equal to 1 is called a standard normal distribution. Okay. And the bell-shaped curve that represents a standard normal distribution is called a standard normal curve. Okay, so what that does is that it normalizes. Okay, so it kind of basically what you do is it kind of rescale it so that the middle is 0, and these are standard deviations. So instead of using the actual numbers like this over here, what they do is they kind of standardize it. Okay, and so we're going to learn how to do that. Because every information has different numbers, and you're going to need different curves for every for different problems. So by normalizing it, you can use that one standard normal distribution curve to use it for all the problems. Okay, so again, this means you basically what they do is they scale everything into standard scales. Okay, and then from there, what they do is they're using the table, okay, to figure out the percent of data within that region. Again, we're going to cover that as we go over the example. It will become more clear. Okay, so what the table do is that whatever number you look up, that would be the area or the probability or the percent of the data from the 0 to the number you're looking up. Okay, and the x would be your standard deviation. So let's say if you look up 1.0 standard deviation, so from 0 to 1 standard deviation, the amount of data would be about 0.3410, about 34%. Okay, or in other words, the amount also would be your probability. Okay, so again, as we go over more examples, it will become a little bit more clear. Okay, so with that being said, let's go and look at examples. Okay. So over here it says in a standard normal distribution means you're looking at, so example 1, in a standard normal distribution, what fraction of the data is between 2.6 and 2.8? Okay? Okay. So what you need to do is you need to use this table over here. Okay? So basically what you have is this. So you have this curve. Okay? And so you're looking for the area. So you're looking for, so example 1 on page 721, you're looking for data that's between 2.6 and 2.8. Okay, so basically you're looking at these. Okay, so again, this is the area between 2.6 and 2.8. So what you need to do is go to the table. Okay, so if you go to the table over here, the 2.6 is 0.49. 53. So basically what you need to do first is you need to go and just sketch. Okay, it doesn't have to be exact. It just kind of sketch to give you the visual representation. So here's your 2.6 standard deviation. Here's your 2.8 standard deviation. Okay, so at 2.6, this is the area right over here. Okay, so this area. So when you look up the table, 2.6 is 0.4953, so 0.4953. Okay, so that is the area right over here. That is 0.4953. Okay, when you look up the 2.8, okay, 2.8 is 4974. Okay, that means this whole thing right over here is 0.4974. Okay, so again, whatever number you look up, okay, whatever the number you look up on the table, okay, that is the area from the 0 to that. So when you're looking up the 2.8, the area is from here to here. When you're looking up the 2.6, it's from here to here. Okay, so okay, let me go and get rid of these. So what you need to do is, since you're looking for between 2.6 and 2.8, you're looking for this area right over here. Okay, so that's what you're looking for. Again, you're looking for from 2.6 to 2.8. So you're looking for from here to here. So the way you're going to do that is you need to use this result minus this result. Okay, so in this case, so the area that you're looking for will equal to 0.4974 minus 0.4953. And so this area will equal to 0.0021. Okay, so you look up the data. Okay, when you look up 2.6, okay, that means the 0.4953 is the area from here to here. When you look up the number for 2.8, that area is 0.4974. That is from here to here. Okay, so when you look up 2.6, that is this area. When you look up 2.8, it's this whole area over here. So to find the part that you're looking for from 2.6 to 2.8. That's the part you're looking for. So you have to use this minus that will give you that. Okay. So basically, what you do, you use the end minus the beginning will give you the things in between. Okay. So you need to learn how to sketch these things out and figure out the area. Okay. Okay. So let's go and do more example. So let's go to example 2. Okay, in a standard normal distribution, so again, that's your normal standard distribution. Again, it does not have to be exact. Okay, you can just throw it to help you to visualize. And again, here's your 0. This is your 0 deviation. Okay. Okay, so in a standard normal distribution, what % of data is within 2 standard deviations from the mean? Okay, so your mean is here. Okay, the mean, and again, you convert it into standard deviation. So from the mean, which is the middle, okay, to the 2 standard deviation. Okay, so you're looking for here. Okay, so you're looking for the area of the 2. So you also need to get -2. Okay, so you're looking for area between -2 standard deviation and the +2 standard deviation. Okay. So again, here's your mean, right? So actually, this graph is kind of bad, okay, because it's supposed to be symmetrical. So I'm trying to do a better drawing. Okay. So the middle is about more like right over here. There we go. Okay. So this is the area you're looking for. Okay. Okay, so again, in a standard normal deviation, what % of data is within 2 standard deviations from the mean? So here's your mean. Okay, mean is your middle. Okay, so again, you convert. So 0 means 0 deviation from the mean. That's what they're talking about. And so you want to go from 2 deviations from here and 2 deviations from this direction. So you go to the table, you look up the 2.0. By the way, because the graph is symmetrical, so the negative, you can also use this table. So -2 and +2 have exactly the same number. So you look up the 2.0 right over here. So 2.0 is 4772. Okay? So that means this area is 0.4772. And this also is 0.4772. Okay? So this whole area will equal to just add together or times by 2. Doesn't either way. So 0.4772 plus 0.4772. So the area will equal to 0.9544. Okay? Or if you convert to percent, it would be 95.44%. Okay? So 95.44% of data would be within 2 standard deviation. Okay? And later on, you're going to learn about probability. So in this case, your probability of data fall within 2 standard deviation will be 0.9544. Okay? So again, this is also probability, okay? And you can learn that later. Okay? Okay, so next what we're going to do is learn how to standardize, learn how to get from the regular data into the standard deviation. Okay, so let's go to example 3. Okay, example 3, it says the height of a certain group adult are normalized, normally distributed with a mean. So that's M. So mean equal to 180 centimeters, and with a standard deviation of 8 centimeters. Okay, so A, you're looking for percent of the group having a height greater than, so your height, so that's H. Okay, so height is greater than 196. Okay, so you're looking for the percent of the people have a height greater than 196. So what you need to do is you need to go ahead and convert into that. Okay, so you want to have height is greater than, so this would be plus 16. Okay, so you want to have it, so this is equal to 16 higher than the mean. Okay, so it is plus 16, right? Use this minus that. So this is 16 over the mean or the average. So you have to convert that into plus or minus. Okay, so this is 16 over, so it will be plus. Then you have to convert into that. So this is greater, so one deviation is 8. So 16 will be equal to plus 2 standard deviation, right? Again, one deviation is 8, so 16 equal to 2 standard deviation. So you have to draw your bell curve, okay? So here's your 0, and 2 is right over here, so that's 2 deviation, okay? And you're looking for greater than, so greater than is right over here, it's this region right over here, okay? Okay, so now you have to go to the table. So when you go look up the table, the 2 standard deviation is this area right over here. So look up at 2.0. Okay. So go to the table and look at 2.0 is 0.4772. Okay. So that's the area from the 0 to the number you're looking up. So this is 0.4772. Yeah. Okay. But you're not looking for this area. You're looking for these. Okay. So what happens is in the probability or normal distribution, the entire curve is equal to 1.0, okay? And so half will be equal to 0.5, and this half will be 0.5, okay? So to find this area, what you need to do is, so the area will equal to, I think they use the x, okay? They use the x, so that's going to follow that. Okay, I think they use, let's see what they use. They use the area. Okay. So this area will equal to 0.5, right? Because that's a half. Okay, that's 0.5, and you're going to minus 0.4772. So again, you have to sketch out to visualize. So you need to know what need to subtract or what need to add. Okay. So again, over here is 0.5. Okay. So 0.5. This whole thing is 0.5. You minus that will give you this, okay? So the area will equal to, get your calculator. Okay, and so 0.5 minus 0.4772 equal, and so this will give you 0.0228, okay? So that's a part for, so this is a part A. Okay, or if you convert into percents, would be 2.28%. So 2.28% of the people will have a height greater than 196. Okay? Okay, now let's go to B. So again, let's go and get the giving. So mean is 180 centimeters, and standard deviation is 8 centimeters. So for part B, you found the percent of group having a height between So you want to have a height between 172 and 180. So between 172 and 180. Okay? Okay, so 172 is -8. And 180 is 0. Okay? Right? So because it's exactly the same, right? Okay. Now, then you convert into deviation, okay? So this would be -1 deviation, right? Because 8 is 1 deviation. So when you minus 8 is, so this is the centimeter, okay, centimeters, okay? And it's less than 0 deviation, okay? So now you get your bell curve. Here's the middle, is 0. So you're looking for between -1 and 0. Again, just sketch it. Doesn't matter exactly what it is. You just want to visualize so you know which area you're looking for. Okay, so this is -1 standard deviation. So you're looking for between the -1 and 0. So you're looking for this area. Okay? Okay, so now you have to go to the table, okay, and you look up the 1.0. Okay, so you look up the 1.0 over here. So it'd be 0.3413. Okay? So this area, again, it's always from the 0 and over to the number you're looking up. So this is equal to 0.3413. Okay? And this one you don't have to do anything because that is, that's what you get already, right? That's a picture you want. Okay? So in this case, the area will equal to 0.3413. And if convert to percent, so it would be 34.13%. So you have about 34% of the people is between 172 and 180 centimeters.